Okay, for problem 14.11, we have an object is undergoing SHM with period 760 seconds and amplitude of 0.320 meters at t equals 0. The object is at x equals 0.320 meters and is instantaneously at rest. Calculate the time it takes the object to go from x equals 0.320 meters to x equals 0.60 meters. So for the very first part, we're gonna have to use these isolation formulas, which is x times t equals to a, the amplitude cosine, the angular frequency times time. And we have to find, in order to use this formula, the angular frequency, which is 2 pi over t, which is time. So we have all the information in order to use this formula except for that. So first we have to solve this one, which is 2 pi over 0.760, and that's going to give us 8.27 radians over seconds. So now we have to solve for t in this formula right here in order to get the time we needed. So we're gonna solve for time first. So t equals 1 over w inverse cosine of xt over the amplitude. So we have to plug 1 over the 8.27 that we already got right here times the inverse cosine, and the xt is 0.160 and the amplitude is 0.320, and that is going to give us 0.127 seconds, and that's the part A. For part B, is asking calculate the time it takes the object to go from x equals 0.60 meters to x equals 0. So I wrote down all the information right here, and we're going to use the same formula we already have right here on the top. So t equals 1 over w cosine inverse 1 of x times t over the amplitude. So we got 1 over 8.27 inverse cosine of 0 over the 0.320 that is amplitude. So we're going to solve for that, and that's going to give us 0.189 seconds. So this is the time for the whole system. So the time will take it from 0.320 to 0. So now, since it's asking only from the 0.160 to 0, we're going to have to subtract the number we got right here, the 0.127. So minus 0.127 is going to be 6.33 times 10 to the negative 2 seconds. And that's the second part. And that's it.